Building a saltwater dummy load. Hi guys, welcome back to the channel. So this is a video about dummy loads. We're in my kitchen and that will become quite apparent as the video progresses. Normally I don't film in the kitchen because there's very little radio related in here. My eye gate is in here. It's just on top of a bread bin which is actually full of paperwork. I don't use it for bread because I don't eat bread that quickly because it's just me in the house. But it's a good place to put an eye gate and a load of paperwork, so there you go. So yeah, we are in my kitchen, as evident by the water filter jug, and there's a teapot there, and laundry soap, and a couple of other things that are in here that are in, well, there's a radio actually, as it turns out. I think I know which one that is. So I had that in here the other day. I don't need fill lights or anything because there's an LED light fitting in here, which, well, I'm not particularly pleased, but, you know, it's the way it's gone. Because the fluorescent one was a bit worse for wear, so they changed it. Anyway, so it's about dummy loads. So these come in all sorts of shapes and sizes. But you can get the really massive ones, which are like paint cans or other metal containers, usually filled with loads of resistors and oil to cool said resistors down, designed for huge amounts of RF. Then you get something like that. This is a Zatagi DL50. CBers will be definitely familiar with that one. This one, you can get these from most of the amateur and CB radio suppliers. They just screw into the back of the radio. I might have got this one from Moonraker, I can't remember. But you can see it's got a heatsink on it, and inside there are resistors that dissipate the RF as heat, which is why it's got a heatsink. On this, it just relies on the metal case. And I did have one size of that. That's actually a short test standard for the NanoVNA, but I don't actually know where that particular one has gone. It's kind of disappeared. But there is another way. And many eagle-eyed viewers to the channel may have noticed this one that I actually built before I actually passed my foundation a long time, which is why it's labelled 27 megs. It's basically, I can bring that up, it's basically a jar, it's a glass jar, that's all it is, and 2 copper electrodes in there, some salt water. This actually needs topping up and redoing. That's just one of the slight drawbacks, and I'll just take the lid off this one. I just have to be careful because the plastic on that lid is going to be a wee bit nasty. And because I didn't know better, that's actually bathroom silicone sealant. It's the acid curing stuff. And it's got an interesting pattern inside the lid. I don't know what's going on there. But you can see the lid's slightly broken there because the UV from the sun broke that plastic down. Which is a little unfortunate. Because it's an old jar. It's just 2 copper electrodes. They're just made of copper wire. They're not 100% straight. I'll see if I can get that to focus. It might not. And they're connected to this SO239 on the top. And I have checked, and that does actually need to be reworked. The sealant is partly necessary to stop corrosion and partly necessary to stop it leaking. Now that was a peanut butter jar, which I believe I bought that peanut butter from Tesco. But they've since started using plastic jars for their peanut butter, well, you could still use those as well if you want, but glass might be a bit better because it may be a little bit more, well, less likely to melt if you put any high power through it. At 27 megs, that wasn't really a problem because it would have been 4 watts anyway for the most part. I do have a amplifier that works on those frequencies. And now we shall get to the making of this thing. Now, all you need is one of these, like I mentioned before. This is a SO239 square chassis mount socket that I bought at the National Hamfest from Canny Components. And it remained in the car after the car accident, so I couldn't do this video when I wanted to do it. And we also need some copper wire. I've got a piece of this from a well, from a project that I've, well, yeah, it was actually going to use it as ground plane radials for a 4-metre antenna, but I kind of never got round to doing that because I'm going to build a different 4-metre antenna anyway, because I do have a 4-metre radio. I have a Motorola GM350. It's only a 4-channel one, but it does actually work. It does the job. Another piece of test equipment we're going to need is either the VNA, which I've got there, or an SWR meter and a radio to do this. Either way works, but I've got the VNA because it's what I've got. Another option is to use an antenna analyzer if you do have such a thing. Now, you'll notice this wire, well, it's not 100% straight, and I would need to straighten that out. There is a way of doing that. If you put wire like that into the chuck of a drill and just quickly spin the drill round, so the other end's in a vise, one end's in the chuck of a drill, and you pull it taut, it literally straightens it out. I'm not going to show you that on camera because, well, my drill's quite noisy anyway. And, well, I've got to go in there and do the soldering off camera, because to do the soldering on camera would require me to move the camera around. All I'm doing is soldering a piece of wire to the centre of that. Wasn't in focus, but I can put it back in focus. Because all you need to do is solder one piece of wire to that, and then the other side connects to any one of these 4 holes. And then we also need water. I've got plenty of that. We've all got taps in our kitchen. Or you could buy a bottle of water if you really want to do that. I've also got my water filter jug. I've not tried this with filtered water. It's just straight, I've only tried it straight out of the tap and a little bit of salt in there. Now that one that I showed you had iodized salt in it. That is not something I've been able to find for a while, but I only bought it because it's what my now ex-wife preferred, because the standard salt in America is iodized. And I actually found that out for myself when I went over there. So another thing we're going to need is a container. Now I've got this coffee jar. This is a Lidl coffee jar. Other good supermarkets are available, including other cheapy supermarkets. So that's a coffee jar, piece of wire, this connector. And what I've got to do is put a hole in that lid, put holes in that lid, fit this once the wire's actually soldered, because there's no point trying to solder the wire on when it's already in there, because it would melt the plastic in the lid. If you did that with a metal lid, do have a jar like that. So got this jar. This jar's actually a bit smaller for what I like. That one's a very lazy garlic jar. I do keep old jars. Sometimes I chuck them in the recycling, sometimes I keep them for experiments, including this. So that's got a more metallic lid on it, so you could probably get away with soldering this in situ. But I'm going to do this the way I did the other one. Put the lid in the top, then fill it with water. So I'm going to go off camera and I'm going to fit this into there with a piece of wire on it, because all my wire is in there. So I'm going to cut this piece of wire in half, and I'm going to strip all the insulation off both halves of it. That's if I can, without pulling off the ring terminal, because I'm going to need that ring terminal. And I shall be back shortly once I've done that. Just before I go, with these coffee jars, they tend to have inside the lid, but we're going to get rid of this because we don't need it, a little papery insert like that. We don't need that, And I've done this in the past where I've removed them, so you just need to get something under there. I've got one of these. This is a box opening knife. I've just stuck this corner piece under here and lifted that out, and then that just lifts out like that, and then that then separates this from the lid, and that can go in the kitchen bin behind me. So I'm going to head off to the other room and I'm going to get this all ready to go in the jar. That took a little bit longer than I was hoping because turns out that it's actually quite hard to solder that. I'll show you. Which isn't ideal. And the ring terminal I was going to put on the end of there didn't stay attached because crimps don't usually attach to solid core wire when they are those plasticky covered ones. So I decided I will just loop it around like that, which I think is what I did in that. I don't know without taking all the goop out. So what I next need to do is I need to be very, very careful and then bend. Probably a bit too much bend. The wire connected to the centre so that they're spaced somewhat evenly apart. That's as evenly apart as I'm getting them. But if I bring the jar back in, we need to take quite a lot of that off before that's going in the jar. So I'm going to do this by eye, and I'm going to say we'll take off, let's bring the lid in, say about that should do it. I'm going to use these pliers because it's all I've got. My normal snips to do this have mysteriously vanished. So I'll put that there. And put the other one to about a similar sort of size. There we go. So now what I should be able to do is put that into our jar. Check where they are against the bottom. Once I've screwed the lid on. And if they're touching the bottom, which I think in this case they might be, hard to tell. It doesn't focus well on glass jars, as it turns out. Means I'll just need to trim a little bit more off. I'm going to do not too much. That should be enough. Yeah, I'm not showing you this, am I? So I've just trimmed a little bit off one of the electrodes, we'll call it, compared to the other one. Let's put that to one side and I'll cut to the other electrode. Using the cutting bit on a pair of pliers is not ideal, so they're now cut. So let's try them in the jar again. And the idea is they don't want to be touching the bottom. So I'm just going to bring that back in. They are touching the sides of the glass, but they don't want to be touching the bottom because they don't want to be bottoming out. Say if you need to open it and refill it. So that's now done, and they're not touching the bottom. That's fine. So we've now got ourselves an empty jar. So let's have a look at some measurements for that. Get a baseline, we shall say, as it is right now. Just clear some notifications off my phone. There we go. Okay, so I'm going to see if I can rotate that round so I can then go to, I can actually capture from the VNA screen and I can put it up on in the video. So I'm going to connect the patch lead up So dry, the SWR on this thing should be pretty high. If I can get the connector into the top. Okay, so that's connected. And yes, the SWR is pretty high. That's to be expected. Let's go capture device. And download that. It's asking me to... Yep, so that should be pretty high. So I'm going to disconnect it. This connectors are quite cheapy, but it's nothing that's going to bother me too much. I think I might have cross-threaded that actually, which is not ideal. There we go. It's a cheapy connector, but that's fine. I'm going to open the lid. There is something I haven't got yet, but I will come to that. The electrode moved, which did not help. Because I've got some water conveniently positioned there. I'm now going to pour that into here. Fill it as far as I can. I'm not going to fill it too much. That should be enough. And I'm going to pop that back in there and see what it says this time. It's filtered water. I'm not sure how conductive that is. Or not conductive, as the case may be. So let's plug this back into here. And let's see what our measurement is. Definitely different for a filled jar. So let's do another capture of that. So that's currently on 28 megs, that's about 10 meters. So I'm just going to download that image. And now I've done that, let's do the next bit. So I've just got to fetch something. The main ingredient for this dummy load. Salt. Now, if you've ever seen Diode Gone Wild, he some years ago bought off eBay a rather shady electrode boiler, and well, search his channel, you'll find the video and you'll know what I'm talking about. The clue is more salt. Just search for dodgy electrode boiler. He wasn't the only electronics YouTuber to get hold of one of those either. Big Clive at bigclive.com also got hold of one. Now, salt water around electronics is never a good idea. So we're going to take the lid back off. Now, the idea of the salt is it makes the water very, very, very conductive. And we're aiming to have a 1-to-1 SWR, so we don't want too much. We don't want too much salt. Just want a tiny little bit. So, because this is a salt grinder rather than a salt cellar like I used for the last one, this will take some trial and effort, I think. So I'm going to turn it once. I think that might be enough. I will need to stir that with something. Look as has it that I did some dishes the other day, and there just so happened to be a spoon that I didn't put away. Now, to put my fingers in there, it's probably not ideal. So I could benefit from... Right, so put the salt in and give it a stir up. Could probably use seawater for this, but I probably personally wouldn't recommend it. Let's put that back in. This is now salt water. I've got no way of measuring the salinity of that. I've just got to go with whatever is in there. So I'm going to go back to my VNA capturing in a moment. So we're going to connect the VNA back up. We're going to tighten that up. And I'm going to capture that so you guys can see it. And we're looking at it. It's currently on 28.004.4 megs, roughly there. 2.34 to 1. Well, let's try Diode Gone Wild's favourite, more salt. More salt indeed. Except this is perfectly safe, unlike those electrode boilers, which if you put those into salt water, well, if you look at Diode Gone Wild's channel, you know full well what's going to happen. So more salt. Let's try that. But it has actually worked so far. So more salt. I'm going to definitely go more salt. There we go. That's more salt. Let's try that. 3 turns of the salt grinder. Give it a stir up. I really don't like the idea there's a big jar of salt water next to my NanoVNA. Ooh, it's kind of squirmy. I'm just going to make sure these electrodes are more or less where I want them. Because it's AC, no electrolysis or anything will happen, so it won't produce chlorine gas in use. So don't worry about that. All you need to worry about is not spilling it, because it is salt water and that can be quite corrosive when it wants to be. Straight away we have ourselves an improvement. I'm just going to tighten this up even further. Make sure it's on. We have an improvement, so I'm just going to put another picture in for you. So I've got to go back to my phone to do this because I'm screen capturing the device. So we're currently at, same frequency, I've not changed it, 28004. We're now at 1.40 to 1. So I'm going to close that off once I've downloaded that image. And I think we could do with more salt in there, maybe? I think so. Let's take the lid off. Well, I'll take the connector off first, otherwise it'll twist that around. Slightly annoying, but, you know. So take the connector off, take the lid off, pop that there a moment. We're going to add more salt. I'm going to add 3 more thingies of it. I'm going to stir it up again. So we're aiming for 1 to 1, absolutely 1 to 1, because it is a dummy load and that's how we should have it. So let's check my electrodes. They're going to move around a bit because I've not actually properly sealed them up yet, and I was thinking of doing it with 2-part resin, but I haven't got any of that. But then potting a whole jar lid of that, yeah, potting that lid up wouldn't be a good idea because then I wouldn't have access to the threads to screw the lid back on, which isn't good. Okay, so we're going to plug it back in and I'm going to see if see what's changed now. Ooh. So once I've finished turning that, capture device. Yeah, so we're now at 1.34 to 1. This thing's spanning from 10 kilohertz all the way up to 50 megahertz. I think we could put more salt in there. If you put too much salt in and it starts going back up again, tip a bit out, add a bit more fresh water, and then eventually you should get it. But for now, more salt. I am aware I'm putting my hands in there, which is not ideal. So my hands are covered in salt water, which is not ideal. So just make sure that's all okay. Put it back in. Ooh, that's cross-threaded the lid there. Right, let's put it back on. Okay, that started to go back up. So it's at 1.51 to 1. So I think that's started to go back up. I'll move this out there in case that's having an effect. 1.46 to 1. So that's started to go back up. I'll pop that on the screen so I can show you. That's why the VNA is connected to my phone. So I can do that. So what we're going to do is I'm just going to tip a little bit of that out, not too much. And then I'll put a little bit of the filtered water through, because I use a water filter jug primarily because my kettle will scale up badly around here, because for whatever reason around here the water is full of that much in the way of minerals. It's nasty, but you get what you get. So I'm just going to be very, very careful and tip a bit down the sink. And this time, more water. Put my hand in it again. Lid back on. VNA back in. That's actually gone up. Actually, no, it has gone down. Give it a little couple of seconds to settle. Has gone down, but I think I'm going to need to take a little bit more of the solution out and add some more fresh. And while I'm at it, I'll refill this jug because I'm going to need to. Okay, so we'll put the lid back on. Now I've added that extra bit of fresh water, I'm just going to give that a stir first. Make sure it's all okay. So we're looking for 1.1 to 1 or thereabouts. Let's close that. So I'm going to take the next screenshot. I'll get that tightened back up and plug the connector back on. So we're at 1.27 at that frequency. So I'm going to try a teensy little bit more salt, not too much. I'll show you that on the screen first, that would be a good idea. So I'm looking at the device now and I get the scroll wheel if it will behave itself. We're at like 1.17, 1. Starts going back up again when you start getting towards that's 10 megs I think there. Yes, at 10 kilohertz it's about 1.35. So it's almost there. Its lowest is about 18 megs. So I think that's okay. That's fine. I'll leave it at that. I won't fiddle around with it anymore on the video because I could be here all day. But I will set something else up just to show that we're okay if I have a spare radio. I might have a spare radio. It's just whether I can power it is a different matter. So I'll just go find a radio and an SWR meter and we can actually test this. Okay, so I've set up a radio. I've just grabbed a CB radio because it would be the easiest to grab. So I've got this Thunderpole T800. This is a slightly earlier version. It's not the current release version, which I believe has a PA facility on board. We're on channel 20 of UK. I can confirm that actually by moving that switch up there and back down again. So that's on the centre of the UK channels. So we've got this Capo Power and SWR meter. It's not particularly brilliant, but it's accurate against the screw-on dummy load and the Midland 3001 as serviced by Tango 21 himself. So what we can do is we can have a look at that. I'm just going to move it slightly out of the way of the dummy load because it does have a metal case and I can see what it's up to. So I'm going to put this into SWR mode and we're going to turn that to the calibrate bit at the end like that. I'm going to reflected. Actually, it's not a lot. It's not perfect, but it doesn't need to be. As long as it's below, I think about 1.5, we should be okay, because I don't know how much power you can put into that. But right now, as I'm talking, that's perfectly fine. It's fluctuating a little, but I think that's probably because One of the electrodes in there is a bit loose, but it's come loose because I've opened the lid so often. Unfortunately, the drawback with that is it's quite leaky, but because the vast majority of the RF is being dumped into the water as heat, then basically it's all going in there and it'll just heat the water up. That's all it'll do. It's basically like an electrode boiler if you think about it, but less scary and doesn't get energized for long. So I've got the microphone keyed down now. You can see that. And I'm confident I can keep it keyed down for this length of time. And because that radio is about 3 watts, I think. I'd have to double check that, but I'm not going to double check it now. I'm confident it's going to take an absolute age to boil that water. So that's transmitting. And that's not transmitting. Let's put it into the power setting mode, and yeah, you can see that that's putting out pretty much close to the radio's full power. It's not accurate against this dummy load at all. But it's a good, useful piece of test kit if you want to check for radios working. I'm going to put that there. So that's the Thunderpole T800. Good radio, I like it. Can't really fault it. I had a look at the more recent version of that radio as well. That's in the back catalogue somewhere. Thunderpole were very kind enough to send that to me, so I could have a look at it. So I've got the T600 as well, which is also a pretty decent radio for what it is. And I've also got, as you will know, the T3000, which is a very good radio to put into a car or a truck. I can't remember if that's 12 and 24 volts. I think it is. Don't quote me on that. It's been a while since I've actually checked. And of course, they've got their handheld, the TX. I've not looked at that handheld yet. That was something I was going to do, hopefully this year, had the car accident not happened. But unfortunately, the car accident happened before I could get around to getting some money together to buy one. Obviously, looking at radios by buying them out of my own pocket is not something I can do. So I hope you found this interesting. It's a little construction video. Put together a saltwater dummy load. It's just basically a jar of salt water and a couple of bits of copper wire. Now the stuff you can use, this I believe, well, slightly thinner than the ones in that. But you can use wire from old scrap transformers if you want to unwind a transformer. Depends on the transformer, which side of the transformer you'd get that from. There is the Twin and Earth. I had to think of the name of it. I think they call it Romex in America. That works fine. You just take the wires out of that. That's actually, well, that's from Twin and Earth cable. You can get that from electrical wholesalers and DIY stores. Or you could just get the spools of copper wire and you could use that. But in pretty much most, if not all cases, you are going to have to straighten that wire out. And to do that, you just need a drill and a vise. Put the piece of wire in the drill and then in the vise. Make sure it's all tight. Pull the trigger slowly if your drill does offer some control like that. I know some don't. And it takes literally seconds and the wire's straight. And that's what I did to straighten these wires out. So there you go. Cheapest dummy load on the planet. I would say it cost me a jar of Lidl's coffee. Which it wasn't really a problem because I drink coffee pretty much every morning without fail. So I'm always going through coffee. So it cost me a jar of Lidl's coffee. This SO239 connector in the top, you can't see that at the moment. It's the way I've got the thing pointed down. And some rock salt and some tap water or filtered water in my case. And that's pretty much what's in it. And it's alright for a CB, that's fine. Ooh. But I'm not sure I can say any higher power than that. I mean, you can try that if you want, but if you end up shattering the jar, then, or melting it if it's a plastic jar, then that is probably something that means that you've probably put too much power through it. You may also want to put a vent hole in the top as well. I haven't done that in this case because I'm probably not going to be using it too much. But a vent hole would be a good idea, so if it does, pressure does build up in there, it can vent. But that's only if you're going to put lots of power through it. But if you really want to be putting like kilowatts and kilowatts through a dummy load, you really, I think you'd be better off with an oil-filled one. And also, I wouldn't recommend using this as a piece of actual test gear. This is good to check your radio still working, or just as a load to just direct your radio into if, say, you want to keep your radio set up but you need to take the antenna off for some reason, so you could probably run it through an antenna switch and have it switched out or something like that. But yeah, that's all it is. I'll put it onto the reflected mode like so. It even tells you how much power that's reflecting back. That's kind of cool. I haven't really calibrated that properly, but that's fine. But yeah, I'm happy. I can just happily do this all day long. Just key it up. Let's bring the microphone in. So that's the microphone. That's the microphone that actually came with this radio. I've been using it with the T3000 because the original one that came with that, developed a fault. I do have that somewhere. So it's nice to reunite that radio and this microphone. You can see where it's been in the car and the red's all faded. The T800, I will probably put that to some use at some point, but it's been brought out for a demonstration on this video. It was sat on my shelf. It's just being powered by the car jump starter behind me, which is actually still connected to its charger, which it really shouldn't be while I'm doing this. But the radio's not complaining, so I'm not too bothered by that. Anyway, 7.3 for now. I'll catch you in the next one, and have fun making your saltwater dummy loads. Cheap, just need a jar, a connector. In fact, you can even use a BNC connector if you want. And patch lead to connect it all up to everything. And there's some way to check the SWR on it, either an SWR meter, which should be the crudest way of doing it, with a radio, or a NanoVNA, which is what I've been using through this whole video. Anyway, I'm going to have to eat my tea because I've not actually made anything for tea tonight, and also I'm going to have to edit this video, aren't I? Anyway, catch you in the next one.